This is your deoxyribonucleic acid, or your DNA. And this is how DNA replication works. Okay, do you know what DNA is? No? Okay. DNA is what helps create us. It provides instructions to the cells on how to make us. Kind of like a blueprint, like for your body. DNA takes the form of a double helix, which is like a twisted version of a ladder, and the nucleotide within it mainly consists of nitrogenous bases. There's also phosphates and sugar molecules, but we'll get back to those. Now here's the real question. The DNA recently watched Boruto's dad and said, "Hey, I want to be like Boruto's dad, he seems cool." Replication jutsu! Nah, just kidding. Cells need to divide into brand new cells, but the problem is, nobody knows how to do it. So they go to the DNA for the instruction manual. Not just one, the DNA needs to replicate, so each cell has their own set, because each cell does their own thing. It's like the printing press, before it was cool. The DNA strands are kinda like a jacket. They unzip, separating into different strands containing the different bases, in a place called the origin, which contains helicase, the one that separates the strands. Now that the DNA is split, it has taken the shape of a Y, and this is called the replication fork. No, not that fork. Now begins the process of replication. This is the leading strand, which is in the 3 to 5 direction. A nucleic acid named RNA comes in with something called a primer, which comes from primus, and attaches itself to the end of the leading strand. After that, polymerase comes in and walks along the strand, adding new bases in the opposite direction. It keeps going and going until it really hates it. This is called continuous replication. Hold up, we're not done with the step yet. There's still the lagging strand, which is in the opposite direction. Now this time, the RNA sent its multiple primers, to many places around the strand. That's when chunks of DNA come about, called the Okazaki fragments. However, the polymerase can't really go any further, so this is discontinuous replication. Now that these strands are ready and aligned, the primers are swept away and are QC'd for final replication. Looks good enough. Finally, an enzyme called ligase glues together the strands. Once that's done, we wind it back up to a double helix, and congratulations, your DNA has been replicated. Now these cells can divide now. Okay, bye.